In this past week, it was Pascal, Kaylee, and Fermat contest. I wrote the Fermat contest, and I think I got 150 out of 150 in it. And today I'm going to do Pascal question 24 and 25. Hope you enjoy it. Make sure to subscribe my channel. Let's get into the question now. So the 24th question is, Lucas chooses 1, 2, or 3 different numbers from the list, 2, 5, 7, 12, 19, 31, 50, and 81, and writes down the sum of these numbers. If Lucas chooses only one number, then this number is a thumb. How many different thumbs less than or equal to 100 are possible? Let's get into the solution now. So notice that the number in the list follows a pattern. The sum of two consecutive numbers is equal to the sum that is right behind these two numbers. And let's think about if Lucas only chooses one number. So in the question it said if he only chooses one number, then the sum is itself. And none of these 8 numbers are over 100, so there are 8 ways to choose one number. And then we think about what if Lucas chooses 2 numbers. So if these 2 numbers are consecutive, then the sum of these 2 numbers is equal to the number right behind these 2 numbers. And so we can't choose 2 numbers that are consecutive in the list. So there are 7 choose 2 ways, which is 21 ways to choose these 2 numbers. But some of these 2 numbers have sum over 100. And actually there is only one of the sum that is over 100, which is 81 plus 31 equals 122. So there are 21 minus 1, which is 20 ways to choose 2 numbers in this case. Now let's think about what if Lucas chooses 3 numbers. So same as above, we can't choose 2 numbers that are consecutive, because if we do, then we could rewrite these 2 numbers as a number that is right behind this 2 number, and then it will fall back into Lucas chooses 2 number case. So there are 6 to choose 3 equals 20 ways to choose 3 numbers. Same as above, some of the sums went over 100, and they are 81 plus 31 plus any number that is less than 19, and 81 plus 19 plus any number that is less than 12. So then in total there are 7 thumbs that went over 100, and therefore there are 20 minus 7 equals 13 ways to choose 3 number in this case. So then in total there are 8 plus 20 plus 13 equals 41 different thumbs. And we have our answer, which is E. Now let's get into the 25th question. So the question is, we call pair mn of positive integer a happy pair if the greatest common divisor of m and n is a perfect square. For example, 20 and 24 is a happy pair because the greatest common factor of 20 and 24 is 4. Suppose k is a positive integer such that 205,800 and 35k is a happy pair, and the number of possible value of k for which k is less than 2,940 is. And let's get into the solution now. So we know that GCD of 205,800 and 35k is equal to 35 times GCD 5,880 and k, and 35 times GCD 5,880 and k must be a perfect square. So then we know that GCD of 5,880 and k must be a multiple of 35. Since GCD 5,580 and k is a multiple of 35, and 5,880 is a multiple of 35, then we know that k must be a multiple of 35. And we let k equal 35 times m, and then we can have m is less than or equal to 2,940 divided by 35, which is 84. So then we know that m is less than or equal to 84. So then GCD 205,835K is equal to GCD 205,835 times 35 times M, which equals to 35 squared, times GCD of 168 and M. So then we can know that GCD 168 and M is a perfect square. And we have 168 is equal to 2 to the third power times 3 times 7. Since we know that GCD 168 and M is a perfect square, and the only divisor of 168 that are perfect squares are 1 and 4. So M could be a multiple of 1 and not a multiple of 2, 3, or 7. Or M could be a multiple of 4 and not be a multiple of 8, 3, and 7. So case 1, M is a multiple of 1 and not a multiple of 2, 3, or 7. And by the principle of inclusive, we have there are the floor of 84 over 2 plus the floor of 84 over 3 plus the floor of 84 over 7 minus the floor of 84 over 2 times 3 minus the floor of 84 over 2 times 7 minus the floor of 84 over 3 times 7 and plus 84 over 2 times 3 times 7, which equals to 60. And so there are 60 numbers for M that are either a multiple of 2, 3, or 7. So we don't want these 60 numbers in these 84 numbers. So there are 24 numbers that is not a multiple of 2, 3, or 7. And case 2 is M is a multiple of 4 and not a multiple of 8, 3, or 7. So let M equals to 4n. Then n is not a multiple of 2, 3, or 7. And we will also have n is less than or equal to 84 over 4, which is 21. So again, by principle of inclusive, we have there are the floor of 21 over 2 plus the floor of 21 over 3 plus the floor of 21 over 7 minus the floor of 21 over 2 times 3 minus the floor of 21 over 2 times 7 minus the floor of 21 over 3 times 7 plus the floor of 21 over 2 times 3 times 7, which is 15. So there are 15 numbers for which n that is either a multiple of 2, 3, or 7. And we don't want these 15 numbers. So there are 21 minus 15, which is 6 numbers that satisfies in this case. So in total, there are 24 plus 6, which is 30 number that satisfies. So our answer is D. In order to solve these two problems, you need some basic counting techniques and principle of inclusive and exclusive. Hope you enjoyed this video and make sure to subscribe my channel.